Okay, hello students. Today we're going to go over 4.1 and 4.2, discrete probability distribution and expected value. Okay, 4.1, 4.2 objectives. We're going to define a random variable, find the expected value of a discrete random variable, and find the variance and standard deviation of a discrete random variable. A random variable is a variable whose quantitative, circled quantitative, value is determined by a random event. Okay, we use capital letters to denote a random variable, such as capital X, and lowercase letters to denote a realized value, like lowercase x. Okay. Discrete. What is discrete? It means that it comes in whole chunks. Discrete is countable. You can count them. Okay. You're able to list them out. Okay, often finite, but not always. Examples, all positive integers. Okay, 1, 2, 3, 4. The number of steps a person takes running 1 mile, that's discrete. They come in whole steps. Can't have half a step or 3/4 of a step or fractional step. Okay, number of books in a backpack. They come in whole books. Okay, that's discrete. What does the probability mass distribution function of something that's discrete look like? Well, it's a chart. It looks like this, P of X and X, and then we're going to have 1 at the top because these are going to be probabilities, and all probabilities go from 0 to 1. So say that we have our first probability, second probability, third probability, fourth probability, and the values have to be numbers. Okay, they don't have to be like 1, 2, 3, 4, but they have to be numbers. They could be like 20, 21, 22, 23, whatever numbers you want here. But the probabilities are discrete. The values are discrete here. 20, 21, 22, 23. Okay, what is continuous? Continuous is not countable. There's an infinite number of items something could be if it's continuous. Okay, can't list out our values. It's infinite or infinitely close together. Example, all the numbers between 0 and 1. The amount of time it takes a person to complete a mile, you could have hundreds of a second, thousands of a second, millions of a second. The weight of a backpack, again, you could have, half pounds, quarter pounds, 0.3777 pounds. Okay, what does the probability density function look like for this one, the distribution? Okay, it's going to be a curve, some sort of curve, some sort of function. Okay, usually start somewhere and stop somewhere. Okay, and all of the values between, say, I don't know, 0 and 1 here, all the values between two values, all the probabilities, P of X, oops, let's go back here. Okay, this is P of X. All the probabilities are shown for every single value between 0 and 1, all the probability is shown. So it's a continuous function there. This is continuous. Okay, this is discrete. Notice in discrete we have gaps, but in a continuous function we do not have gaps. X there. Okay, probability distribution of a random variable. Okay, 1. Okay, the probabilities sum to 1. Okay, the probabilities have to sum to 1. Okay, and okay, and there's a probability at each value. Okay, this is a probability model. Okay, suppose that the probability distribution function for the following number of years it takes to earn a Bachelor of Science degree is given below. In words, define the random variable X. Okay, well, they kind of just defined it for us. It's the number of years. Okay, X equals the number of years it takes to earn a Bachelor of Science degree. What does it mean for that the values 0, 1, 2 are not included in X? It means that in this case, you cannot get a Bachelor of Science degree in 0, 1, or 2 years. Okay, 0, 1, or 2 years. Okay, the probability of 0 years is 0, probability of 1 year is 0, and the probability of 2 years is 0. Okay, so they're all, for those it's 0, and we just don't list them. Okay, probability of 8 years in this case is 0 as well. Okay, so there's a line in Tommy Boy, funny line that says, he says, a lot of people graduate college in 8 years, and the other guy says, yeah, they're called doctors. So it's a funny line. But anyway, here, no 8-year bachelor's degrees. Okay, what's the probability of a random student taking more than 4 years to earn a BS? Okay, so more than 4 years. So that would be 5, 6, or 7. And we're going to get 0.3, 0.15, and 0.10. So we're just going to add that up. 0.30 plus 0.15. This is the probability of 4, 5, or 6. Okay, or more than 4. Sorry, this is 5, 6, or 7. Let's just say X is greater than 4. Make it easy on myself. Is 0.30 plus 0.15 plus 0.10. If I add all that up on my calculator, 0.30 plus 0.15, 0.30 plus 0.15 plus 0.10, that's 0.55. Okay, so which is 55%. You could leave it as a decimal or a fraction, doesn't matter. Okay, key ingredients of a valid probability distribution of a random variable. Okay, the sum of all the probabilities must be equal to 1. We went over that. Every individual probability must have a value between 0 and 1. Okay, and I'm going to put a third one here, is that the random variable must be quantitative. Okay, it cannot be categorical or qualitative. Okay, that should be an N right there. So hard. Quantitative. Okay, it must be quantitative. Okay, why aren't the following situations examples of probability distribution of a random variable? Well, let's look at, do they sum to 1? Yes, they sum to 1. Are the probabilities between 0 and 1? Yes, both of them are between 0 and 1. Is the random variable quantitative? No. Heads and tails, these are qualities. Okay, these are categories of a flip. So this is not quantitative. Okay. Senior executives were asked when job applications should discuss salary. The table below was created for their responses. Okay. Are the outcomes, are the X values, are they quantitative? Yes. Okay. Are all of these between 0 and 1? Yes. Do they add to 1? Well, what's 0.30, 0.26, and 0.10? 0.30 plus 0.26 plus 0.10 is 0.66. So this does not equal 1. Okay, the sum does not equal 1. Okay, so that's the problem there. Okay, so the sum does not equal 1. So the problem over here is that for A, it was not quantitative. For B, it's that the sum does not equal 1. Okay, the mean or average value of a discrete random variable variable is calculated using mu equals EX, okay, or I'll put parentheses there, E of X. Okay, this is called the expected value. Okay, E sub X is the expected value. And it's the sum, that little sigma sign just means sum. This is sum. Okay. It's the sum of all the x's times their respective probabilities. The x values times the respective probabilities, and then we add them up. Okay, the mean of the random variable is the sum of every value times its probability. Interpretation in the long run over many trials, the outcome would average out to mu. Okay, variance. Variance is the square of sigma, which is the square of the standard deviation. So the variance of x is equal to the sum of xi minus e of x squared. So we get the difference. This is the difference between the x values and the mean. Square that and then multiply by the probability for each value. Okay, this is also the expected value of x minus the expected value squared. Okay, so sigma here is equal to the standard deviation of x, which is the square root of the variance of x. So if I take the variance and I square root it, I get the standard deviation. If I take the standard deviation and I square it, I get the variance. Okay, so they have a square root relationship. Interpretation of standard deviation in the long run over many trials, on average, we will get a value about sigma units away from the mean. Okay, let's find the expected value, variance, and standard deviation for a random variable. Let's see how this works. Okay, so we want the expected value was that sum of the x's times the probabilities. Okay, so how does this work? Well, I'm going to take the first x value, which is 10, and multiply by 0.3. And then I'm going to take the next value, 20, and multiply it by its probability of 0.5. And then I'm going to take the last value, 30, and multiply by its probability, multiply by its probability of 0.2. 10 times 0.3 is just 3. 20 times 0.5, that's half of 20, that's 10. And 30 times 0.2 is 6. If I take 3 plus 10 plus 6, I get 19. So that's the mean, okay, or mu. Mu is 19, okay, or E sub x, expected value. It's the same thing. Okay, so I'll just put E of x. E of x is 19. Now let's find the variance, okay, the variance. The variance of x is equal to the sum of x minus E of x squared times the probability of x. So let's see how this works. So we're going to go x, which is 10, minus 19 squared times the probability at 10. That's 0.3. Plus, this is 20 minus 19 squared times 0.5, plus 30 minus 19 times 0.2, 30 minus 19 squared times 0.2, okay? So 10 minus 19 is negative 9, that's negative 9 squared times 0.3. This is 20 minus 19, which is 1 squared times 0.5. This is 30 minus 19, which is going to be 11 squared times 0.2. Okay, so let's square these out. This is going to be 81 times 0.3. 1 squared is 1 times 0.5, and 11 squared is 121 times 0.2. Okay. Okay, if we go to the calculator, we can go 81 times 0.3 is 24.3. 1 times 0.5 is just 0.5. And 121, oops, wrong calculator. 121 times 0.2 is 24.2. Okay, if I ever go too fast with the calculations, feel free to just pause or rewind me 10 seconds, and then you can pause, write this down, and then continue on. Okay, so this is going to be equal to, put the equal sign there because I'm running out of room. Okay, the variance is equal to, let's add this up, 24.2 plus 0.5 plus 24.3 is 49. So that's the variance. The variance was equal to 49. That's the variance of x is 49. Now, what about the standard deviation? It asked me for the standard deviation. Well, the standard deviation is just the square root of the variance. Standard deviation of x is equal to the square root of the variance of x, which is going to be equal to the square root of 49, which is 7. Okay, so the standard deviation was equal to 7. Okay, so variance was 49, so expected value 19. Variance was 49, and the standard deviation was 7. Okay, how can we do this process on the calculator? Because this is a nightmare of a process if we get a long list of probabilities. Okay, it's just a lot of computation, a lot of places to go wrong. So let's do it on the calculator, and we'll do it on StatCrunch. We'll do the first problem on the calculator, and then we'll do the second problem on StatCrunch. Okay, so let's go, let's do example 5 here. It says find the expected value, variance, and standard deviation for the random variable. Okay, so on the calculator, let's go to the calculator real quick. Okay, I have programmed in here, I believe. Okay, 2 lists. I have L1, which is my X values, okay, 2, 4, 8, and 10. Okay, and then I have my probabilities for each of those values, 0.3, 0.4, 0.2, and 0.1. Okay, so 0.3, 0.4, 0.2, and 0.1. Feel free to pause and plug those into your calculator, okay, under stats and then edit. Okay, stat and edit. So now what I'm going to do for those is I'm going to go to stat key. Let me clear this real quick. Okay, I'm going to hit the stat key, and I'm going to go to calculate, and I'm going to go one variable statistics. So just hit arrow over and then enter. And then I'm going to go list 1, L1. I want to go, what's the frequency list? Okay, this is the first time we've used this. What's the frequency list? And the frequency list are those probabilities. This is going to be L2. Okay, so how do I get L2 if I didn't have this? If I cleared it out, if I don't have it, I go second, 2, second, and the number 2. And that will populate list 2. L2 is list 2. And then we arrow down and hit enter, and it calculates for us. It tells us that the mean X bar is 4.8. Tells me that the standard deviation is 2.7129. Okay, 2.73 basically. 2.713, we'll say. So 2.713. Okay, so this doesn't give me the variance, I don't believe. No, it doesn't give me the variance, but we'll get it in a second. Okay, so the mean, okay, the mean was 4.8, and the standard deviation was 7 point, what was it again? 2.713. Okay, 2.713. Okay, but what if I wanted to find the variance? Well, how do I find the variance given the standard deviation? Well, I just square it. The variance is sigma squared. So if I take 2.713 and I square it, okay, so let's clear this, 2.713, and let's square that. I get 7.36. Okay. Yeah, 7.360 basically. So we'll just round that to 7.36. Okay, so 7.36. That's it. So we got our mean, our standard deviation, and our variance using the calculator. Let's do example 6. Let's do example 6 using StatCrunch this time. Okay. It says a large auto dealership keeps track of sales made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Okay. Based on previous records, the probability distribution X is shown. The probability of selling 0 cars is 0.3 or 30%. Probability of selling 1 car is 0.4 or 40%. Probability of selling 2 cars is 0.2, and the probability of selling 3 cars is 0.1. Obviously, the probability of selling 4 cars or more is 0. Okay. Is this a valid probability distribution? Well, are the X values all numbers? Okay. Is it quantitative? Yeah. Are all the probabilities between 0 and 1? Okay, between 0 and 1. Yep. Okay, and what do they add up to? Do they sum to 1? 0.3 plus 0.4 is 0.7, plus 0.2 is 0.9, plus 0.1 is 1.0. Okay, so that does equal 1. Okay, so yes. Okay, so all 3 criteria checks. Okay, numbers, yes. 1 equals 1, yes, and all the probabilities are between 0 and 1, yes. Okay, so yes, it is a valid probability distribution. Okay, use your calculator. We're going to use StatCrunch. StatCrunch. Use StatCrunch to compute. If you don't have StatCrunch, use your calculator again. Okay. Use StatCrunch to interpret the expected value, and using your calculator, compute the standard deviation. Okay. These notes were designed to go with a calculator. Okay, but if you don't have a calculator, you just have StatCrunch, then okay, you can use StatCrunch. Now I've already plugged in the values here. Okay, so 0 cars, the first column is cars. 0, 1, 2, and 3 cars sold on a Friday. Okay, the VAR2 here is the probabilities, 0.3, 0.4, 0.2, and 0.1. Again, if you need to pause the video and plug in these values for yourself, go right ahead. Okay, welcome back. We're gonna plug these in, and now we're gonna calculate. Okay, so I'm gonna go to stats, I'm gonna go to calculators, and I'm gonna go down here to custom. Once again, that's stat, calculators, and custom. Okay, and it says, what are the values in select variable X? Okay, var1 are my X values. That's the values that I'm working with. And what are the weights? The weights are the probabilities. Okay, how are they weighted? Okay, that's var2, and then I'm going to click compute. And it gives me, okay, the mean and the standard deviation. Okay, it tells me the mean was 1.1 and the standard deviation was 0.943. So let's do that. The mean, okay, E of X is 1.1, and the standard deviation, okay, standard deviation of X is equal to 0.943. You could have used mu X bar. Okay, mu is 1.1 and sigma is 0.943. Do that as well there. Okay. Okay, now it says interpret these values. It says don't just compute it, interpret it. What is E of X equal to 1.1 mean? Okay, well, this is the average number of cars sold on a given Friday. Okay, on Fridays, we could say. Okay, what about interpret the standard deviation? Well, the standard deviation, okay, is the amount of variation from the mean, okay, or from the expected value, averages 0.943 standard deviations away. Okay, it's 0.943 standard deviations from that mean. Okay, in a lottery game, a player picks 6 numbers from 1 to 26. If the player matches all 6 numbers, they win $50,000. Otherwise, they lose $1. What is the expected value of this game? Okay. Okay, so we want to know what is the probability of winning the game? Okay, what's the probability of winning the game here? Okay, so you have to choose 6 numbers, okay, out of 26, but you got to choose the correct 6. Okay, so we want to know basically first, how many ways can we choose 6 numbers choose 6 numbers from 26. Okay, how many ways can we choose 6 numbers from 26? Okay, so let's think about this for a second. Okay, so let's just say that the first number that I choose could be, you know, say any of the 26, right? So for the first number, I have 26 choices. Okay, for the first number, I have 26 choices. Okay, but for the second number, I've already locked in that choice. So for the second number, I have 25 choices, and then 24 choices, and then 23 choices, and 22 choices, and then 21 choices. Okay, so I already have that as my choices. Okay, so those are locked in. Okay, and so it's 26, 25, 24, 23, 22, 21. Okay, so those are the choices that I have, right? So say I choose a 1 first time, then I could choose 2 through 26, right? So then 25, 24, 23, 22, 21. Okay, so my choices go down 1 by 1 each time. Okay, however, this isn't, if I did it this way, then I could have them in any order. Okay, any order I could choose. I would have, you know, meaning that there's the same number, the same outcome for, or there's a separate, I should say separate, sorry. There's a separate outcome for 1, 2, 3, 4, 5, and 6, and 6, 5, 4, 3, 2, and 1. Okay, so those are 2 different outcomes. But right, so how many ways could I choose? How many ways could I choose 6 items though? Okay, because if I don't care about, if I don't, if these are, if we're going to say these are the same, then I have to divide out the repeats. Okay, so I have to divide off the repeats, the repeated values. Okay, I could choose the same 6 numbers, but they just be in different order. But it doesn't matter because with the lottery, order doesn't matter. And because order doesn't matter, they're just going to get ordered anyway later on. Okay, order doesn't matter. I'm going to end up with 6, 5, 4, 3, 2, and 1. Okay, for the values here. So what I'm saying here is that I have to divide off all of these permutations or different arrangements, okay, from what I got for the 26. Okay, so 6 times 5 times 4 times 3 times 2 times 1 is called 6 factorial, but that ends up being, let's go to the calculator, 6 times 5 times 4 times 3 times 2 times 1, okay, is 720. Okay, so there's 720 different ways that I could rearrange 6 numbers that are the same, okay? And what I'm going to do here is I'm going to divide off my 720. So I'm going to say, okay, 26 times 25 times 24 times 23 times 22 times 21 over 720. Okay, that's going to give me the different combinations. Okay, this is the way of, out of 26, choose 6 items. Okay, this is when order does not matter. Okay, if order mattered, then I would just have the 26, 25, 24, 23, 22, and 21. But here order doesn't matter in the lottery, and so I just know that I just have to divide off by the 6, 5, 4, 3, 2, 1. Okay, so the different ways that I could rearrange 6 items. So we're going to do 26, 25, 24, 23, 22, 21, and then divide by that 720. So let's do that on the calculator. So 26 times 25 times 24 times 23 times 22 times 21 equals a very big number. Now let's divide by 720. And I get 230, 230. So this is what I'm looking for, 230, 230. That's the number of ways, okay, that I can choose six items out of 26. So there are 230,230 ways to choose 6 numbers from 26. Okay, so a little probability in there. Now, okay, how do we find our expected value? Okay, so E of X is going to be the outcome times the probability. The outcome, well, the outcome that I want is to get $50,000, but the probability is going to be 1 out of 230,230. That's the probability. Okay, plus the other outcome is that I lose $1. Okay, so that's -1 times the probability of me losing. Well, the probability of me losing is 1 minus the probability of me winning. So that's actually 230,299 over 230 times 230, all over 230,230. Okay, so I'm going to plug this into the calculator and calculate this out. I'm going to go 50,000 times 1 divided by 230,230. Okay, that gives me my first value, plus 1 negative times 230,299 divided by 230,230, it equals, and I get -0.78. okay, negative 0.78, about negative 78, which this is in money. Okay, this is in money. Okay, so my expected loss is about 78 cents. Okay, so I have an expected loss. Okay, of 78 cents. Expected loss of 78 cents. Okay. Okay, last example here. Okay, a company estimates that 3% of their products will fail after the original warranty period, but within 2 years of the purchase, with a replacement cost of $150. If they want to offer a 2-year extended warranty, what price should they charge so that they'll break even? In other words, so that the expected value will be 0. Okay, so let's find out what is the expected value here. Okay, what is the expected value? So we want to know what should they charge? Okay, okay, so 3% of the time, okay, 3% of the time, they're going to have to pay out $150. So 0.03 times 150. Okay, that's what they're going to pay out. Okay. Okay. But okay, right? So 0.03 times 150. That's what they're going to pay out. Okay, so that's a win for us, right? However, make sure that I'm doing this correctly. However, it really is minus the amount of money that they would have collected from us. So that's minus C. Okay, so 150 minus C. Okay, that's the amount of money that they would have collected from us. Okay, it's 150 minus the amount for the insurance policy. This C is the amount for the warranty. Okay, so they're going to pay out $150 minus what they've already collected, minus whatever what they've already collected as a premium. Okay, plus 0.97% of the time, they're just going to collect my money. Okay, so they're just going to get my C here. Okay, so they're just going to collect. They're going to collect my money. So, yeah. Okay, so and we want this to be 0, right? Okay, so make sure my signs are correct here. Okay, we're having C be negative in this case. So I think I want this to be a negative as well. Okay, let's make that a negative C. Okay, because that's money that we paid in. Okay, and that's money that doesn't come back to us. We have to pay that money in. So I'm going to make that a negative C. Okay. Okay. So we're going to say distribute this. This is 0.03 times 150 minus 0.03 C minus 0.97 C is equal to, okay, is equal to 0. Okay, so 0.03 times 150, what is that? 0.03 times 150 is 4.5. Minus, this is going to be 0.03 C minus 0.97 C. So I'm going to add those two negatives when I subtract two. When I take a negative and subtract it from a negative, I'm basically adding the opposite. And when I combine two negatives, it's adding and the result is negative. So this is 0.97 plus 0.03 is 1.00 C is equal to 0. 1 times C is just C. So this is 4.5 minus C is equal to 0. Okay, I could add C to both sides of the equation, and I get 4.5 is equal to C. So that would be the cost of the warranty. Okay, cost of the warranty is 4.5. I'm going to put a 0 and a dollar sign because we're going to, so it's $4.50. So if I collect $4.50 from from a bunch of people, okay, say 97 out of 100 people, right? I collect that, then I will end up paying out, okay, you know, to 3 people, $150, and they will offset each other. Okay, okay, that's it for 4.1 and 4.2. I'll see you in the next video for 4.3.